Today, Open Source Security is talking to Andrey Smirnov, engineering lead for Talos Linux at Sidero Labs. Andrey, I am so excited to have you on the show. Thank you for coming.
Thank you, Josh. Excited to join and talk about security. Yeah,
Yes. Okay, so I'm going to start with maybe a little preface. And I told Andrey this before we hit record, but so as a podcast host, whenever I learn of a project, I always want to try it out. And we had a listener some time ago suggest I talk to Andrey about Talos Linux security. And I apologize, I did not write down who suggested this. So if you're listening, give me a shout out and I'll add your name to the show notes or something. But anyway, so I'm like, okay, I'm going to take a look at this because I've heard of Talos and never used it. I installed Talos Linux as I started using it. And holy crap, it has changed my life. I'm never going back to Minikube or Kind or any of the other small Kubernetes orchestrators because this thing goes from tiny to huge and it's amazing. So, okay, Andrey, let's just start up by tell us what Talos is because holy cow, it is cool.
Yeah, I think it started with exactly like you described, started with an idea that, I'm not the founder, right? So founder is Andrew, almost same as my name, but different letter at the end. He was managing like many ops people do, a huge number of Kubernetes clusters rolled out with Kubespray, Ansible, and all that stuff. And I think the biggest problem was it's easy to roll out a cluster, but how do you keep it up to date, keep it running, update it, upgrade it, whatever, right? And there came the idea that general Linux distros, whether it's Debian or Ubuntu or Red Hat, whatever, they might not work so well when your only goal is to run container-based workloads or Kubernetes in general. Because what does Kubernetes need from the host OS? It's probably not that much, right?
Yeah.
And also, there is this, you don't need users on the host. What are the users? Kubernetes doesn't care. And then one idea on top of another idea, let's make it more secure. For example, what if we make the root file system immutable and read-only? That will improve the security. What if we drop some stuff that you don't need? There is no shell in rootfs on Talos at all. And what if we make it small? What if we make it upgradable by changing the whole image? So there are many, many ideas layered one on top of another. And together, I think they form that feeling that Talos is very easy to run Kubernetes on, because literally you boot Talos and Kubernetes is up.
Yeah.
I don't think in general that Talos is limited to Kubernetes, but I think the way our industry looks today is that everybody wants Kubernetes if they want to run anything in containers, even though if Kubernetes is an overkill for their specific use case.
Yeah.
We have users who run single node Kubernetes clusters, which seems why, right? Kubernetes was designed for exactly opposite use case, but still people, I think Kubernetes is the way to run containers today, at least that's what it is.
Yeah.
So,
and I want to add, so if you look at the docs, there is the ability to run basically a test instance on a single node, which I use often for demos and things for work and whatnot. And you can also scale this thing to the moon, which I feel there aren't a lot of systems on the planet that can do very small and very big, which is cool.
Yeah, and also what we're really proud of, it's literally the same Talos image that runs anywhere. Whether you put it on Amazon, or you run it in Kim, or you run it on Raspberry Pi. Well, Raspberry Pi might be different architecture, but still comparing ARM, ARM AWS instance and ARM Raspberry Pi, it will be exactly same byte by byte Talos image that runs on it.
Yeah.
Which gives you almost same experience, plus minus, still environment gives a bit of a difference, but you expect almost same 99% same Talos Linux everywhere.
Yeah.
Where it runs.
And I want to stress the horrible experience of trying to manage a Kubernetes cluster, if it's just some Debian nodes, because that's what I used to use in my basement when I would do Kubernetes testing, is I had a bunch of Debian systems that I would SSH into. Talos doesn't even have SSH, so it's not an option, but I'd SSH into, and then I'd say there's a 95% chance I was going to screw something up so bad I just threw everything away and started over. which
Yeah,
is,
exactly.
I think, a lot of Kubernetes experiences for people where it's just like, it's broken so bad, it can't be fixed, and we're just going to start again. Which, in the case of Talos, I can do with a command. Like one command, and it works. Okay.
And I think it goes into some way to, before working on Talos, like long time ago, I was working on open source tool, which is still alive, which is called aptly. And the whole idea of aptly was to be able to take snapshots of Debian package repositories. So because if you do like apt update, apt upgrade, right, in general, the result depends on the time you're running this command, right?
Yep.
It might be a bit different. And if you want all your machines to be exactly in sync on the same package version, that tool was actually trying to do one step of it by like providing you a way to snapshot, but snapshot was the basic function of it. So you take a snapshot of the upstream repository, publish that as a repository, and like point all your machines to it, so you know they run exactly same versions. And when you want to upgrade, you upgrade, but it's in your control, right?
Well,
and I think Talos takes it to the next level, but saying there is no package manager at all. You just upgrade the base OS and you get the new set of packages, and it's immutable set that was tested together, and you don't have a way to upgrade one component without touching another for most of them.
Yeah. And we should also add, so you have a command line tool. It's what Talos CTL it's called.
Yeah.
And it is how everything happens. There is all of the communication between the nodes. The magic is your own protocol that is kind of built into, I guess, I don't know what you call it. Like
it's Talos API.
API. Okay. Yeah.
Yeah. Talos API. And if you think on the surface, like most of the Talos API is actually read-only. You want to know the state of the machine. Most of that state is exposed as resources, which are very similar to Kubernetes resources. So you can see how my like time sync is going, or what are the addresses assigned to that machine. That will be all resources. And some commands which actually change the state. I would say, like, you want to reboot a machine, or you want to apply a new machine configuration to it. And that's the only, like, applying new machine configuration is the only path to actually change the machine. And Talos will just accept the new machine and on the fly reconfigure itself to do something. I don't know, whatever your machine config change is, whether you attach a new address statically to the interface, or you want to change Kube API server version, Talos will figure it out and reconfigure itself on the fly for the new. But that's literally, that replaces the shell. So there's no shell, but the only way you apply the change is by applying the machine config.
And I must also say, I will embarrassingly say, my favorite feature I think you have is that I can acquire the config file I need to run kubectl anywhere I'm at by running one command. Because like that is always such a pain. It's like, wait, which kubectl do I have on this machine? Oh, is it that one? Oh no, it's not that one. Oh crap, where'd I put it? I can't find it. And so that is like been the most delightful part of this whole experience, is just being able to easily grab the kubectl I need, and it just works. It's amazing.
Yeah, exactly. So the idea of Talos, once we even try to see that as the OS you shouldn't be worried much about, right? It's kind of a zero OS in the sense that if you figured out your machine configuration, figured out your provisioning process, you can like scale up your cluster by throwing more hardware, applying the same machine config to it. They will all join your cluster. And once you have kubeconfig, you have the Kubernetes. That's what you were looking for. You weren't looking for Talos specifically.
Right.
Your idea is to run your workloads. Like you said, you have your kubeconfig, and now you can start kubectl applying your stuff or whatever you want to run on top of your cluster. And Talos gets out of the way as much as the next time you need it is something goes wrong and you want to troubleshoot things or whatever. Apply the change.
Yeah. I haven't broken it yet, so we'll see if I change my opinion when I break something. But okay, so this is supposed to be a security show. So let's talk about the security of this, because you folks have done, I think, some really clever things around, immutability, not running SSH, kind of the minimal attack surface, kind of next level almost, I would say, in what you've done. So explain kind of the security ideas and some of the things you've done, and we'll kind of weave our way from there.
Yeah, I think one which you mentioned, right, is one on, I think I have like three things that I think we can split this all into.
Cool.
One is, yes, don't put something you don't need, basically minimal set of dependencies that you ship, and naturally you will have, you don't have to worry about that. That's probably like, once again, like going back to, Ubuntu or something. In the default install, it might have something that you actually don't need or never use, but it might have a vulnerability on its own, which might force you to upgrade. So being minimal is one thing. Another, I guess, is being like bleeding edge. So we try to update all our dependency to the absolutely whatever is available at the time Talos is released, whether it's like the Linux kernel or whether it is like Kubernetes version that we support, etcd version. So we try to like use the latest ones. You get, whenever Talos Kubernetes release is available, the next one, there is a Talos release which supports this version. There's no that you have to wait 1 year to try a new Kubernetes version.
Right.
And the third thing, I guess, is like these design choices, or when you say your rootfs is read-only and immutable. That's how you design the OS. Or that, for example, in Kubernetes, we enable by default pod security. That, like, we enable pod security to make it the best for our users. Certainly, what we get back is users asking, how can I deploy my workload? Now Kubernetes yells at me that, I don't know, my privileged pods are not running. Yeah, so we have to teach and explain, and I think kind of to push the community to explain, yes, this is a cool thing that actually enforces best security standards. Yes, it's a bit painful if you want to run something which is privileged. You have to explicitly mark and say, okay, I'm okay with that being privileged in that namespace because I know I'm running whatever, my Rook Ceph storage, and it needs to be privileged for good reasons. But in general, to force things to be like in the best way possible. Also, I think we pushed a lot of third-party products because, for example, like, once again, I'm talking about storage solutions, but what they love to do is to have a privileged pod, then from that pod enter PID1 namespace and execute bash from it. And that doesn't work on Talos for the best reason that there is no bash, right? So come on, like, either you ship your tools with you, or if you do need to get into root namespace for whatever reason to run some tools, at least don't rely on shell being there. So we had to, like, actually many projects had to do some changes to run on Talos for that way.
But that's the best reason, right? I mean, this is, I think, the typical security attitude of if it's not default, no one uses it. I mean, by forcing the immutable file system, by forcing, the secure pod, all of that changes behaviors because you have to change. Like, right. I love it.
Yeah, exactly. Yeah, immutable file system is also like sometimes whatever, someone comes up with the community question, how do I run this workload? But it tries to mount from the host something from etc as writable. And Talos like doesn't let you do that. And how do I run it? Does your actually workload needs to run something from host etc as writable, right? Is it like
the answer is
doing
no.
A good job?
Yeah, the answer is always no. Like, you don't need to do that. You just do it because it was easy and you got lazy and then you never went and fixed it again. Like, there's a joke in the world of machinists I've heard that is, there's nothing more permanent than a temporary fix. And like,
yeah, exactly.
In software, I totally feel like that happens. So, okay, I want to talk about immutable file systems because I feel like that is not necessarily a totally understood concept. I think it sort of makes sense, but I'm sure even I don't totally understand it. So tell us what that means and how it works. Because obviously when we think of immutable, like, we can never change it, right? And obviously that's the goal, but we have to upgrade sometimes too.
Right, exactly. So if you think about that, like, Talos today ships as two files, if we simplify it. One is the Linux kernel image, and another one, which is like in Linux world called initrd, initrmfs, whatever we call it. And this is whole Talos. Today, we package that into a single file even called UKI, Unified whatever kernel interface. I think it's basically EFI bootable. So you can literally boot that single file over whatever network or like USB stick, and that's the whole Talos. But like Linux kernel, we understand that it's kind of immutable because that's the kernel image. And the initramfs itself in traditional operating systems might contain some small initial set of tools, which is enough to mount the actual like root file system, which will be on disk. In Talos, initramfs is actually self-contained. There is no root file system on disk at all. So inside the initramfs, it's more about like Linux specifics. Initramfs can be made read-only, but inside initramfs, what we ship is a squashfs image. And squashfs is one of the read-only Linux file system, not the only one, but one of the possible options. So what happens is that in the early boot, the initramfs is there available. Inside, there is a squashfs image, which is exactly read-only. And what Talos does, it mounts that squashfs and makes it the root of the whole like mount tree. So when we boot, there is nothing writable by default because the whole like everything under / is read-only at this point. And we start mounting on top things that need to be writable. Like we want /tmp to be writable, so we do tempfs. We need some required file systems like /dev and stuff like that, which is Linux specific things. They're neither writable nor read-only. They're kind of system files, like file system. But that's the initial state of Talos. And Talos can, up to some point, run in the state where there is no block storage available yet, right? So everything is in memory. Most of that is read-only. And then once we push configuration to Talos, or Talos finds its already configuration that was persisted to disk, it will start mounting additional things. And the only like big writable part of the Talos file system tree is /var. So that will basically come from disk. That will contain things like container images. If that's a control plane machine, that, well, etcd by default stores its database. It's where there is like all these empty-dir, like container state. All of that goes to /var. And in general, if it's not like a control plane machine, if it's a worker, you can consider this /var to be somewhat ephemeral, because the container state is usually something that can be recreated if it is lost or it is wiped. If you want some persistence, for example, you run a database, probably you would rather allocate a specific volume for its contents, right? But you won't like mix it with, in general, like /var. But that's the only thing that is writable. Like usually when a container starts, like something like a pod, which is a bad pod from pod security standards, which tries to do hotspot mounts, but still, when it starts, the only thing it can mount as writable is something under /var in general.
Okay, so I have a question then that I don't know the answer to. So you're talking about hosts being ephemeral. So if I reboot a Talos node, is the configuration information stored on disk, or does it reacquire that from the cluster when it boots up?
Yes, the default behavior is actually stored on disk. So I probably skipped that part, but I was more talking about how the boot process works. Yeah. But in general, like Talos when you install Talos, by installing literally means that you put a bootloader and that boot asset file, which is a single file of like UKI to disk. Talos will allocate some system partitions, which are very tiny.
Yeah.
One of them will be used to store the files, including the machine configuration. So once you like install, it's there. But some people, for example, want to run completely opposite of that. They want to run ephemeral Talos node, which boots over the network. Everything is tempfs. And if you reboot that node, that usually is a worker, obviously, in Kubernetes world, right? It's all gone. Like there's no trace left. It is completely fresh. But usually people, they would rather have some persistence. Yeah.
For sure. Okay, so what does an upgrade look like then in this immutable universe?
Upgrade is very simple. So we literally pull new boot assets over the network from some source. In case of Talos, usually it's the container registry, so it's another image. We unpack that and write new boot assets to the boot partition. And we reboot. That's it. So as the whole Talos is contained this UKI file, and this UKI file is what? It's around 100 megabytes, probably a bit more.
It's really
today.
small. Yeah.
Yeah, that's the whole thing. You just lay down a new one and you reboot to use this new image, and that's it. You get the new Linux kernel, probably if you use the new Talos version, and you get new initramfs, which contains that new immutable image, which comes with new like tools or new Talos core code, and that's it. There is nothing else. And you can also roll back, right? So we keep at least 2 boot assets available. So if things go wrong, you can basically in the bootloader say, I want to boot previous version.
That's super
kind
cool.
of this A-B scheme. This is, I think it's very simple when you talk about that. And it is very simple, but this idea is quite different, right? From what many operating systems do.
It feels better though, because again, I'm not SSHing into a Debian system that I've messed up more ways than I can count. Right? Like I love the idea. Immutability, I don't even see as much as a security feature as I see it like it is a way to protect myself from myself. Because like present me hates future me, and I'm always screwing that guy over, right? I cannot do that with this. So I love it. Okay, let's talk about, I want to talk about the minimal aspect as well, because you say on your website that like there's no SSHD running in these systems, right? It is strictly over your API that things communicate, that configuration gets set. And I feel like that is a concept we are not used to in the world of computers, right? We are used to connecting to a system, sitting down at a system, monkeying with it, in my case, breaking it, and then walking away, right? Whereas that is not at all what this does. And it is amazing and I think terrifying at very first to think you can't do anything to this.
Yeah, you have to accept that, I guess, because there are certainly like pros and cons. Like on one hand, like you said, if you know you can't touch it manually or manually modify something, that means that the machine is totally in the state that was set by the configuration. On the other hand, you feel that you don't have all the tools and all the power you had like over decades of Unix, Linux that are available to you usually. Like you want to run, I don't know, IP utility. No, you have to learn that that's now a resource and you have to do like, I don't know, get addresses if you want to see addresses instead of IPA or something. And I think it's always a compromise we have because we try to build that completely new system that operates on a different paradigm, like the API level, right? And we certainly can't be like feature complete ever. If you compare that to a regular Linux distro and someone says, oh, I want to set up some VLAN and connect it to a bridge this way. And if we don't support this today, we have to add support for it, right? So that is always there, that kind of going back and forth. And in the end, you have to sometimes, until we add like real first-class support for something, you have to rely on some hacks to make it work, which certainly is not the best. So you have to kind of accept the fact that you will be limited in some ways. If that works for you, if what Talos Linux offers is enough, you're in a good spot because you get all the benefits. If you need something that is absolutely not supported by Talos today, probably you either have to wait, right? But you might not have the best experience. So I guess there is this compromise.
That's a fair point. Yeah, it's not something I'd really thought, but I'm not doing anything exciting either. I'm just running simple Kubernetes instances either on my laptop locally or a couple of nodes I have that are just VMs, out in my network, and I don't have VLANs or anything. That's interesting. That's fair. And yes,
we do
it should
support VLANs, right? But it sometimes comes to it. I want to have a bridge, like for example, dumb example, but still, like Talos assumes that if it manages something, it manages it.
Sure.
For example, like if you create a bridge with Talos and attach some ports to it, Talos will ensure that this bridge exists and only these ports are attached to it. And then someone says, oh, I want to run KubeVirt, and KubeVirt will attach something else to that port. Or it could be not KubeVirt. I don't remember exactly.
Okay.
And then Talos sees, oh, there is a new port that I'm not aware about, removed, right? Because what Talos is built internally on is like Kubernetes concept of like constant reconciliation. So if it notices a change, it will try to reconcile it back to the state it should be in. So it will, for example, like revert. If you like go and, I don't know, what is a good example? Like go and manually delete an address from the link that was managed by Talos. Talos will go and add it back. Nice. It will say, no, it should be there. So I will add it back. It won't let you even like drift from the configuration that was supposed to have.
But I like this because I am notorious for SSHing into a node, like creating some weird firewall rule or port forward or something, forgetting I did it, and then spending like 10 hours in a month trying to figure out why something isn't working. And it's because I rebooted the machine and now my firewall rule is gone. So I feel like that is a good thing.
Yeah, so it's certainly, I do feel the same way, right? And we try to add as much stuff as we can with each release and support new things. Sometimes it takes time to actually figure out. We don't want to like copy or like basically re-implement the way let's take a simple example. How do you manage your storage in general? Like in traditional Linux, you will SSH in, you will do something like gdisk or whatever, fdisk, like partition that, make a fast something, right? Then go to a fast tab, mount that. Certainly, for example, with systemd, things are changing and it offers like better ways like auto mounting based on partition, UIDs and stuff like that. There are many changes there, but like traditional ways, more like very manual, you have to configure this and that. And with Talos, we thought, okay, we don't want to do that. We want that experience to be closer a bit to how Kubernetes allows you to allocate resources. So we want to have something which is I want to have a user volume and I specify the size I want it to be, like the file system, it should be the name of it. If I want to be specific about which disk or disk type it needs to use, like I want it to be on NVMe disk. That's all I put. And Talos will figure out, allocate that on a proper drive. If like for the first time, next time it's there, it will just use it. That's a bit different experience from like traditional OS that we're offering in many places. And sometimes it takes time even to figure out what is that correct way to, I don't know, allocate your disks, for example.
Yeah. I mean, your docs are pretty good. I figured that out quickly. And I'll tell you my experience. You know what I did? I SSH into my system. I set up the file system. I forget to add it to the FS tab. I mount it manually. And then when I reboot, the disk is gone and everything explodes. Like that's my usual experience with this. So
right.
That, I think that's the reason I love this is so much and why I just like was instantly enthralled by Talos is because it has like removed my ability to do dumb things. That I think is the most appealing aspect of this. But okay, Andrey, I could talk to you all day. I'm not going to. We'll have to have you back at some point. But I like let's take us home. I'll give you the floor. Talk about whatever you want us to know. Like, what's a good way to try it out? How can we get involved? What does this project look like? Like, fill us in on kind of next steps for anyone listening that's interested.
So, I mean, yes, everything on GitHub, github.com/Talos.
And I'll have links in the show notes for everything. Yeah. So anyone who's interested, just go check those out.
So we have, we're pretty open in the way we do development. So like issue pull requests, like it's all open. We even have our planning board in GitHub projects, also like open to everyone. We do need help in many areas, right? I think lots of projects would say that we need more testing. We need like more great bug reports. And I really love our community when they find some very non-trivial bugs, when actually finding the bug or finding the root cause of the issue is way more complicated than fixing it. Fix might be one liner, right? But go figure out why this happens. We certainly do need help in these areas, in the documentation. We like coding is, for example, I don't know, I can say that we hired 2 people to our engineering team just because they opened cool enough PRs.
Awesome.
Yeah, you just like see there was a person comes up with a PR to add like hardware watchdog support for Talos. And I know they never asked any question. They just, the PR is not perfect, but the way they figured out like all the way how to do this, like how to do machine configuration changes, how like to connect things together. And I say, oh my God, right? This person never asked a question and they're able to do such a PR. They figure out how to test that and all that stuff. So yes, we need to talk. So certainly PRs were very, very open to that. We recently started adding more. I mean, it's interesting. We started adding more like security related stuff, as for example, S bombs. I would say they're certainly they don't guarantee security on their own, right? But we hit lots of interesting issues on that way. For example, with the CVE database not being accurate all the way, like you run the scan on your like perfect SBOM what you think. I mean, it perfectly describes all the components, but then you get CVEs which are just incorrectly reporting the like fixed versions, or sometimes they're like appear 2-year-old CVEs randomly appear once again with the wrong version attached to them. So we started doing this vulnerability exclusion file to fix it up, to have actually a clean run on our. But we try to be serious about the security. For example, you can't like merge a pull request to Talos if it doesn't pass the gripe scan on SBOM.
Nice.
So if there is a new vulnerability, and same for like Go dependencies, like specifically with the Go vuln check tool, we just say, okay, we have to stop whatever we were doing, go back and update something that needs to be updated, whether it's like Go toolchain that reports a vulnerability, or like whatever. We need a new Linux release to get it fixed.
Nice.
We'll go back and try to fix that. We kind of try to fly these zero CVE, at least at the moment it gets released, because certainly over time, Linux kernel will certainly publish like at least a handful of CVEs, I guess, in a month.
A handful, a bucket full, I think, those guys.
Right, but that's what we try to do. We try to have these patch releases which update components, affected components, and we really love like our users to upgrade and get it. We try to make this upgrade as much like not scary, I would say, as we can, because certainly there is also, I think, in the industry, there's a thing that people hate to upgrade.
Yes.
In general, and that doesn't help, right? And we try to make sure that at least there is a release available. I know some users trust us that much that they set up automatic upgrades, which is certainly sounds a bit scary, right? But probably if it's your home lab or something and you know a way you can recover, right, or roll back, that's fine. But certainly, I mean, I would recommend to, we have lots of stuff like that. And you mentioned like a way to create local Talos clusters, and we had support for like QEMU on Linux for a long time. And in the very last release, we added support for macOS, basically to use their native, QEMU using their native hypervisor on macOS, because it turns out many people today who are doing stuff, they have their Mac laptops, and this is I think very cool, because I like the way it runs inside a VM, that you can actually experiment with anything. I mean, you can boot your small cluster in the VM, apply your workloads, your production ones, and try out an upgrade or try out a config change, see how it goes. That is way, it certainly doesn't replace staging environment, but sometimes that's a way easier to experiment with things, I would say.
Yeah, and it runs in Docker. Like I'm running it on my laptop in Docker, which is amazing.
Yeah, Docker like still doesn't give you the full experience, like upgrades are not available and stuff like that. Or you run with the host Linux kernel, not with the Talos one.
Yeah. But still, it's very easy.
Talking about security, for example, we have a kernel hardening checker running against our kernel config all the time. This cool project which includes like things like KSPP and other recommendations built in. So we try to make sure, we certainly do have exceptions. I should admit, we had to like flag some things that as acceptable for us, right? But we still try to do whatever is the best security practices in kernel configuration.
Nice.
Or getting back to, I think security is painful.
Yeah.
I can give one more example of that. For example, when we build kernel, Linux kernel, I mean, we create a completely ephemeral signing key, which is discarded after the build, and we sign the kernel modules with that key, and the key itself goes into the kernel, which means that after this is built, nobody in the world can actually build a kernel module that Talos will accept and load. Which certainly makes it painful sometimes when someone says, oh, I have this proprietary driver kernel module that I want to run on Talos, and there is no like source available, so we can't like really give it to you guys so you can include it into your build system and sign it. But at the same time, that means that you can't like at least provide any exploits by loading a kernel module. That path is just not available.
Right. And you probably don't have the tools, because I know like I used to work at Red Hat and we did exactly this, where we would sign all the modules with an ephemeral key, throw it out. And then if someone needed to sign or wanted to load signed modules, they had to then load another key into the kernel key store, and then it could do it. But that's a bunch of extra tooling and probably not as friendly on an ephemeral, or I'm sorry, a read-only file system. Anyway.
Yeah, we were looking into that. Usually the problem is that you want that available super early. What if that thing is a network driver, right?
Right.
So we're looking into actually offering a way to embed your own custom key into the kernel image, which kernel supports, but that would still require you building a bit of a your own image. But I mean, what I'm trying to say, that is painful. Like,
super painful.
Same thing will like apply to, for example, NVIDIA. We can't offer like the way NVIDIA operator usually works is that builds literally like checks out like Linux source tree, like NVIDIA source, and builds on the same machine that kernel module and loads it. And sorry, this is not available with Talos, so we have to pre-build NVIDIA kernel modules, make them available as what we call like extensions. So actually Talos, when I say it's minimal, it's still true, but when people want something else to be there, they have a variety of extensions they can pick from and use what we call image factory to actually create your own image, when you can pick with the checkboxes, oh, I want this and this. So you can pick your NVIDIA extensions bundled in. You will have your image, which already contains the NVIDIA kernel module. So you have just to load that, or like, but still we can't offer how NVIDIA envisioned that because of that module signing, which is just won't work.
Well, and this is hard to do on a traditional Linux distro, and you're running it in hard mode. So
yeah, so we had like lots of pains with that, or whatever, or NVIDIA once again like strikes again the way it works. It relies very heavily on glibc. It assumes that it is there on the host, and it will mount that up into the actual like container workloads, which are enabled to NVIDIA. And Talos doesn't have glibc. It's based on muscle-C. Once again, for security reasons, we try, like the C library is muscle. We don't have glibc in the default install, but if you do NVIDIA, we actually have, once again, an extension which provides you glibc, but that is already installed to non-default location, because we can't install to default one because muscle is there, right? So, but that non-default location is, once again, I have cascading panes that to teach NVIDIA container runtime where it is, and that's in a different location. You have to use it. Yeah.
Oh my goodness.
So lots of pain. We made ourselves for ourselves like suffer, but trying to offer actually better security out of the box.
I love it. I love it. And that we're going to end it there. That's perfect. Yes. Better security out of the box. That's fantastic. And Andrey, I want to thank you so much. This has been fascinating and I have learned so much. I appreciate it.
Thank you, Josh. Thank you for having me. That was a great conversation. Yeah.